Okay, so just like double time, there also is an approximate half-life formula. And so the time it takes to achieve half of it is actually, it looks like the same formula, 70 over p. Keep in mind that our growth rate is going to be different for percentage versus doubling. And again, this is an approximation, so it's only going to work decently up to about 15%, and after that we want to use a more exact formula. Okay, suppose the inflation causes the value of the Russian ruble to fall at a rate of 12% per year relative to the dollar. At this rate, approximately how long does it take the ruble to lose half of its value? Okay, so the time it takes for half is going to be 70 divided by the percent that they gave us, so 70 over 12. And then I want to go to the calculator and type that in. So 70 divided by 12 is 5.833. So about 5.8 years, the ruble will be worth half of its value. Okay, so now I want to give you the exact formulas at this point, so you can appreciate the approximation here. So the time that it takes to double, the exact formula is log of 2 over log of 1 plus r. And the time it takes for half is negative log of 2 divided by log of 1 plus r. So we kind of have to know where to find this log button. Let me kind of pull up my calculator here. Now, let's see, you want to look for this button here when you end up doing logs. And you kind of want to know how your calculator does it. So, I say log of 2. So notice it already freaked out on me. So for me, I want to hit the number first and then hit log. So again, you want to know what your calculator does in order to use it correctly. And if you're not sure, then shoot me an email and I can help you figure out how to hit the buttons properly in your calculator. Okay, so population of rats is growing at 80% per month. Find the exact double time using the growth rate and compare it to the double time with the approximate formula. So let me write out that exact. So we're going to use the exact. Would be log of 2 divided by log of 1 plus 0.8. Now the approximate would be 70 divided by 80. So you can kind of see that there's a benefit when we can approximate it versus use the exact, because it looks a little easier. Okay, so let's see. So for me, I'm going to hit 2 log and divide that. 1 plus 0.8 is 1.8, so 1.8. And I would take the log of that and divide. So I get 1.18, 1.18 months. And then versus the other one, which is 70 divided by 80. So that's 0.875. Okay, so notice, not even close. But in all fairness, we do have the rule that says we can only use the approximation formula up to about 15%. So we knew going into this that 80% was clearly outside that range. And so our approximation method wasn't going to give us a decent estimate on that at all.